The Pedro T. Orata National High School proudly presents this school year 2020 to 2021 Science Experiment ko sa Bahay, Ibabahagi ko online is brought to you by the Science Department. This activity aims to showcase learners' potentials in science discipline in pursuant to Regional Memorandum Number 581 Series of 2020, which is known Virtual Celebration of the 2020 Science and Technology Week. Behind this preparation were collaborative efforts among learners from the junior high school and senior high school level with the guidance of their science teachers, Marichu Galinato Shador, Venus Diaz Bernardino, Alden C. Bernardino, Gloria de la Cruz Ramos, Minerva Nunales Terceño, with the initiative of school administrators headed by Dr. Gemma B. Prestoza, Principal 3, Sir Danny L. Valentino and Ma'am Jovel B. Castro, head teachers. Amidst pandemic, learners develop values such as leadership, independence, technology literacy, self-discipline, and creativity. That pandemic will not stop their learning and their individual progress. With that, let us witness the compiled science experiment videos prepared by the Pedros with the hashtag Science Experiment ko sa Bahay, Ibabahagi ko online.
Hi, I'm Christina Molina and I will be doing an experiment about heterogeneous and homogeneous mixture. So first, I will tell you what is a mixture. Mixture is a substance made by mixing other substance, and it is a material made up of two or more different substances which are physically combined. So without further ado, let's get into our experiment. Materials needed. So let's add oil to the water. And let's mix it up. Let's mix it well. And this is the result. When you add oil to a cup of water, the two don't mix up with each other because oil is less dense than water. It will always float on top of water, creating a surface layer of oil. So this is an example of heterogeneous mixture. You might have seen this on the streets after a heavy rain. Some water puddles will have a coating of green oil thing floating on them, just like this. So next is, let's add sugar to the water. And let's mix it up. Just like the oil and water, let's mix it well. So this is the result. Sugar dissolves and is spread throughout the cup of water. So this is an example of homogeneous mixture. So this is an example of heterogeneous and this is homogeneous or solution. So I hope you like my experiment video about homogeneous and heterogeneous mixture. So that's it.
Good morning, everyone. My name is Eunice P. Mendoza.
And I'm Crystal and I'm Espino.
And we are grade 7 Browns
From Pedro T. Orata National High School.
Our experiment today are solute, solvent, and solution.
The materials we need are plastic cup, plastic spoon, water, sugar, salt, and pebbles. Firstly, let me teach what is a solution. Consider 3 cups of water.
In the first cup, add the salt in water. Let mix.
Second cup, add a sugar and water. Mix it together. Third cup, add a pebbles from water.
Mix together. After some time, I observe it. Salt is completely dissolved in the water. Salt are soluble to the water and form a homogeneous mixture, uniform composition. We can see particles.
Sugar is completely dissolved in the water, so sugar is soluble to the water and form a homogeneous mixture, uniform composition. We can see particles. Pebbles are not dissolved by water, so pebbles are not insoluble in the water and form a homogeneous mixture, non-uniform composition. We can see particles.
Now listen carefully. Salt and water are soluble with each other to form a homogeneous mixture. So it's a solution.
Sugar and water are soluble with each other to form a homogeneous mixture. So it's a solution. Pebbles are insoluble in water and the form is heterogeneous mixture. So it's not a solution. To define the solution is a homogeneous mixture of 2 or more substances called a solution.
Solute and solvent. Salt solution. We know that the salt solution have two components, salt, water. Secondly, we know that the salt are dissolved into the water. Thirdly, we know that the salt present a smaller quantity and the water present a larger quantity.
Sugar solution. And the sugar solution have 2 components, sugar and water. Secondly, we know that the sugar are dissolved in the water. While in a sugar solution, sugar is present smaller quantity and water present larger quantity.
The components of solution which is present in a smaller amount is called solute.
The components of solution which is present in a larger amount is called solvent.
So salt solution is a solute because it is present a smaller amount. And water is solvent because is present larger amount.
And sugar solution, sugar is a solute because it is present smaller amount, and water is solvent because it is present larger amount.
Why water is universal solvent?
Water has the potential to dissolve many substances. But remember, this is only polar.
Polar substance are polar solute are soluble in water.
Non-polar substances are non-polar, solute are not soluble in water. Thank you for watching.
I'm Daphne M. Tablada from grade 7 Broads. Are you curious about solution and its type? Today, we're going to have an experiment.
Solution like sugar in water has two components. The two components of solutions are: number 1, solute, the substance that dissolves in solution. It is usually present in a small amount. Number 2, solvent, a substance that dissolves a solute. It is usually present in greater amount. Solubility is a maximum amount of solute that can dissolve in a given amount of solvent at a certain temperature.
Here is an experiment about three types of solution based on the amount of dissolved solute and solvent. Here are the materials needed in our experiment: brown sugar, spoon, glass, and water. The solute in this experiment is the sugar, because sugar dissolves in solution and usually present in a small amount. The solvent in this solution is water, because the water dissolves sugar and usually present in greater amount. Okay, let's start.
Unsaturated solution is a solution that can contain less solute than the maximum amount. The solvent can dissolve a given temperature. Its color is lighter than saturated and supersaturated solution.
This is an example of unsaturated solution. Next type of solution is saturated solution.
Saturated solution is a solution that contains the maximum amount of solution dissolved by a given amount of solvent. The color of saturated solution is intermediate than unsaturated and supersaturated solution.
This is an example of saturated solution. The last one is supersaturated solution.
Supersaturated solution is a solution that contains more solute than the maximum amount the solvent can dissolve at a given temperature. Its color is darker than unsaturated and saturated solution. It has excess solid which can no longer dissolve. Let's now sum up. A solution is a special type of homogeneous mixture composed of two or more substances. There are three types of solution: unsaturated solution, saturated solution, and supersaturated solution. Hope you learned from this experiment. Thanks for watching!
Hi, mom and classmate. I'm Gianna Ayan Kasam and I will do an experiment. So my topic is solution, colloids, and suspension. First step, add sugar in water. Then mix it. Second step, add powdered chalk in water. Then mix it. Third step, add powder milk in water. Then mix it. Direct a beam of light through each cup. The particles of sugar have completely disappeared in mixture. Such a mixture is called homogeneous mixture. Homogeneous mixture means consistent, uniform throughout. The particles of sugar are very small. They cannot scatter any light. Hence, we are unable to see the path of light inside the homogeneous mixture. Such a mixture is called a solution. They can observe some chalk particles freely moving in second mixture. Such a mixture is called a heterogeneous mixture. Heterogeneous means non-uniform. Light is directed through the second cup. Here the path of light is visible inside the heterogeneous mixture. The particles of chalk are insoluble in water and are big enough to scatter the light passing through them. Such a mixture is called suspension. This effect of scattering of light is called tyndall effect. Size of particle in a suspension is usually larger than 100 nm. However, these particles eventually settle down. After some time, the tyndall effect may not be observed in suspension. Let's have a look at the third mixture. Path of light is visible through the mixture. Mixture appears to be homogeneous. Observe under a highly powered microscope. Mixture to be homogeneous, but it's actually heterogeneous mixture. Such a mixture is called a colloid. Size of particles is between 1 nm, 1000 nm, and a colloid. The particles never settle down, hence the tyndall effect is always observed in colloids. So that is the example of solution, suspension, and colloids. Bye!
Good morning, everyone. My name is Mark Joseph M. Opiaza.
And I am Daniela D. Mendoza. And
We are grade 8 students from Pedro T. Orata National High School.
Our experiment for today is testing the density of an egg over water.
Materials needed: 2 bottles, water, 2 eggs, salt, 2 scissors, and tape.
Let's begin. First, let's put the salt in the one bottle and stir.
Second, let's put the eggs in both bottles, 1 egg each.
Third step, let us now fill the bottles.
Plain water with egg. Water and salt with egg.
Ladies and gentlemen, what do you think? Which in these eggs will break?
After the experiment, we can answer the question.
Let me go first. I will drop this plain water with egg and let's see the result. The egg is cracked.
Next, let me drop salt water with egg. It's not cracked.
See the difference.
Let me explain what is happened. When we first did the experiment, the egg sank immediately because the egg density is higher than the liquid in which was placed. Density is the characteristic of an object in relation to how dense it is when there is more mass or quantity matter within a space. It is dense. To determine the density, it is necessary to divide the mass of an object by the volume or space occupied by it. When the bottle with egg dropped, the egg hit the bottom of the bottle due to the impact. When the experiment was reported, we noticed that the egg floated in the water because the salt and water was mixed. The salt with water is more dense than the pure water to float the egg. Did not broke because it did not hit the bottom of the bottle but was protected from impact due its floating in salt.
And that is the simple experiment that shows off amazing science.
Thanks for watching!
For today's video, gagawa tayo ng science basic experiment. So, ang kailangan natin ay So, ngayon, kailangan natin basain yung paper.
Kailangan lang natin dito. Kailangan natin dito ba? So ngayon, itry natin dito ng dalawang baso na may tubig. Kalahati lang to. Nabuhat na ang dalawang baso na may tubig. Ito na po ang basic science experiment.
Hi, this is Gwen Granit Garnet. For this video, we're going to do a basic science experiment. To do the experiment, we need 2 glasses of water, salt, 2 eggs. First, let's put 1 egg in the water and let's mix it. Next, let's add salt in a separate glass of water. And then, let's put the egg in the water. As you can see, the egg in the water sinks, therefore, the egg inside the water with salt floats. And that's it for my basic science experiment. Hope you enjoy!
Materials needed in this activity is plate,
Colored water,
candle.
mat,
Since we don't have clear glass, we use a tumbler.
so let's start.
Tablada.
I'm Larry Jane A. Castillo.
We are grade 9 student from Pedro Orata National High School.
Magandang araw, ako nga pala si Isabela Mayoblera, estudyante ng Pedro Orata National High School. Meron akong ipapakilala sa inyo na kung saan pwede siyang maging solid at liquid. Ito ay ang yoble. Kailangan lang natin ng 3 materials para magawa natin ang experiment nito. Water, cornstarch, Ang timpla ng cornstarch at tubig ay lumilikha ng isang likido na kagaya ng buhangin, na kaysa naman sa tubig. Ang paglalagay kasi ng persa natin dito sa yoble kagaya ng pagpisil o kaya paghalo, ay mas lalo siyang nagpo-form ng solid kasi yung mga buti niya mas lalong nagsasama-sama. Tignan natin ang ngayon. Kung sa una, makikita natin na solid siya bagamat nakahawakan natin siya ng maayos. Pero ano kaya mangyayari kapag binitayan na natin siya? Unti-unti siyang natutunan. Ano nga bang paliwanag nito? Kagaya ng nasabi ko pa kanina, ang yoble ay isang non-Newtonian fluid, pero nagpo-form ito na kagaya din ng solid. So ano nga bang ibig sabihin ng non-Newtonian fluid? Ang non-Newtonian fluid ay isang likido na kung saan ang lakit niya ay hindi pare-parehas at saka hindi niya sinusunod yung Newton's law. Subukan niyong paggalawin ng mabilis ang yoble at obserbahan ang nangyayari. Hindi ba't matigas siya? Pero kapag dinahandaan naman natin, unti-unti na siyang matutunan. Kagaya nito. Ang yoble ay hindi nakakalason, bagamat gawa lang naman ito sa cornstarch at tubig, pero maaari itong mag-cause ng sakit ng pananakit ng no. Alam niyo ba na pwede tayo makapaglakad sa yoble? Bagamat natagpuan ng mga researcher na meron itong 5 to 20 microns ang lapad ng bawat butil ng starch. Kaya imbis na may halo ito sa tubig, ay lumilipat-lipat lamang ito ng posisyon. Hindi ba't kamangha-mangha? Again, I am Isabela Mayoblera, student of Pedro Orata National High School. Thanks for
Hi guys, I am Jonalyn M. Adviento.
I am Carlos Socabras.
And I'm Charlotte Cuesta.
And we are from grade 9 Jasper. Today, we're gonna show you a really cool experiment with water and ground black paper.
Start by taking a plate
We like to use a white one like this.
and pour on some water.
Take your paper and sprinkle a bit all over the water.
Like this, you can see the paper sits on the surface of the water.
And if you dip your fingertip in, nothing really happens.
You might get some paper stuck to your finger, but that's about it.
Next, take some washing up liquid and wipe a tiny amount on the end of the finger.
Like this, then you try dip your finger into the water.
Again, as you can see, the paper seems to magically shoot away from your finger.
Now, here's what's happening. The paper sits on the water.
Because of the high water surface tension, the water molecules are strongly attracted together. When we add a little soap, we break down this surface tension.
In the top layer of water, molecules very quickly spread up.
And carry the paper with them pretty cool, huh?
And if you use less paper, you're able to spread out even further. We hope you enjoy.
We are grade 9 students of Pedro Orata National High School.
We will do an experiment called baking soda volcano experiment.
The materials that we need to use are plastic cup, baking soda, and vinegar. And if you want your experiment to be colorful, you can use any kind of food coloring.
First, we put the baking soda on the plastic cup. If you want your experiment to be colorful, you can use any kind of food coloring. And last, we put the vinegar.
What happened to the baking soda in our experiment that we did?
This compound break up when they come in contact with vinegar. The carbon and oxygen separated to form a gas and carbon dioxide. Because bicarbonated of soda is a compound of sodium, hydrogen, and carbon and oxygen.
And that's the end of our experiment. Hope you enjoyed our experiment and try it in your home. Again, we are grade 9 students of Pedro Orata National High School.
Hello learners! I'm Alea. I'm Elisha. And I'm Francine. And today we're going to present the Immortal Candle. These are the materials that we are going to use. First is the water, clear container, glass, matches, and especially our recycled candle.
We know that the oxygen has a big factor. That's why the time you use it to cover the candle with the light, oxygen will be accumulated inside it, so the light will not stop and continuously lights on. That's all for today. Thanks for watching.
The Sci Guys present Boys Law. We are the Sci Guys. I'm Gracie. And I'm Janice. Today's video, we will present to you our experiment about Boyle's Law.
Boyle's law is an experimental gas law that describes how the pressure of a gas tends to increase as the volume of the container decreases.
Before we start our experiment, here's the materials needed. First, the balloon. Second, the scissor. And the last one is the empty plastic bottle. So let's start. First step, cut the bottom part of the balloon. Second step, create a hole at the bottom part of the bottle. Third step, put the cutted part of the balloon into the bottom part of the bottle. For the last step, put another balloon on the top of our bottle. And then, our final output should be like this.
And I'm Jerome T. Sulyat. We are the grade 10 students of Pedro Orata National High School.
Today we're gonna do an experiment called
Instant Ice.
Materials needed is just
a bottle of water.
are confused
on how the water turns into ice instantly.
Good morning guys, I'm Steven Kalubaybayan, so I'm here now to explain on how the instant ice works. The trick for this experiment is super cold water. You're catching the water when it's cold enough to freeze, but hasn't quite frozen yet. This triggers the crystal to form, instantly hardening of the ice inside the bottle. The weather term for this process is what we call snap freeze.
versus fire. What will happen if you put a balloon in fire? Let's find out.
This could be the very minute I'm aware I'm alive. All these places feel like home. With a name I'd never chosen, I can make my first step.
When the candle is light, the flame hits the air inside the glass, and the hot air expands quickly. The outside air pushes water into the container until the pressure is equalized. The water stops rising when the pressure equalization is reached. To put it simple, the air inside the glass has lower pressure than the air outside of the glass. The higher atmospheric pressure from the outside pushes the water from the plate up into the glass.
morning, everyone. Welcome to Sci Guys. I'm Gemma.
And I'm Melanie. And welcome to our series on the laws of gases. Charles Law.
Under volume Charles Law. A student that the volume occupied by a fixed amount of gas is directly proportional to its absolute temperature if the pressure remains constant.
It is a special case of the general gas law and can be derived from the kinetic theory of gases under the assumption of a perfect ideal gas.
The first step would be prepare the baking soda solution. You will need 1 leveled off teaspoon of baking soda. You want 1 even teaspoon of baking soda. This will be placed in a small glass.
To the glass, you will add 7 tablespoons of tap water.
Stir the solution until it's no longer cloudy and all of the baking soda has dissolved. This may take a
When your baking soda solution is prepared, you can take 1 tablespoon of your solution and add it to a tall glass.
Then add a small amount of liquid dish soap and stir to ensure that dissolves.
Using a ruler or other measuring device, you should measure the width of the glass.
And you will measuring the height of the bubble column that is generated.
We'll take 1 tablespoon of vinegar and add it to the glass.
Notice the reaction takes place. This carbon dioxide that is generated is trapped in the bubbles.
Using your measuring device, you can then measure the height of the bubble column.
Based on the geometry of the glass, being a cylinder, you determine the volume of gas that was generated by the reaction.
You can then compare this to calculate number of moles that should have been generated from the reaction.
And using the ideal gas law, determine what percent error is in this experiment.
Thank you for watching.
Robert Boyle was Irish-born in society, was an founding view in Royal Society. His work in chemistry and made establishing is on mathematical science based on the machine and theory of math.
Si Medyo Ribado, 12 pearl.
And like a Medias Twestal, 12 pearl.
Boy's Law Balloons Experiment.
bottle, thumbtacks, scissors, balloons. First step, cut the balloon in half. Sa thumbtack and poke a hole in the bottom of the bottle. Cover the bottom of the water bottle with the top of the balloon. Pull balloon into the top of the water bottle and stretch the top over the opening. Pull on the balloon on the bottom of the bottle. The bottle inside the bottle should infinity and infinity as you do this.
Hi everyone, I am Malgrea.
And I am Joyful.
Today we're going to show to you an experiment about Charles' Law.
So first, we need 2 glasses with the same size.
Then, kailangan din natin ng 2 layer of tissue and scissors.
At panghuli, a small candle, matches, and a small bowl with water.
First, put the candle inside the glass.
Second, cut a hole in the middle of the tissue paper, then put it in the rim of the glass, basain ng konti ang circumference.
Third, light the candle and dip the rim of the glass in the bowl with water. Then, ipatong ito dun sa glass na may tissue at candle. The wet tissue between the 2 glasses of water will form an airtight seal. Walang hangin na makakapasok o makakalabas dahil dito.
We can use plastic or leaf para gawing seal dahil madulas ito pag nabasa. Unlike the tissue paper, sakto ang porousness or dami ng butas ng wet tissue paper.
When the gases inside the glass are already cool, the volume will decrease. It's because of the Charles' law. The volume before over the volume after is equal to the temperature before over the temperature after.
Ibig sabihin, the volume of the gas is proportional to its temperature if the pressure is constant. So kapag nag-decrease ang temperature ng gas, the volume will do decreases.
And that's our Charles Law experiment. See you next time.